Cool. Okay, guys, today we are going to look at how to implement caching in ASP.NET Core. So without wasting any time, we already have created a folder where we want our application to reside. So now the next thing to do, as usual or as always, is to actually create the application itself, and we use the .NET CLI. So the what do they call these things? The code to do that here, that application, because say caching. Let's just call it caching. This is all you need to do. This is the code that you need to do to create a new application, and we're going to press enter. We're waiting for the framework to create the application. The template was created successfully. Cool, our application has been successfully created. So there is it. So I believe that we all know what is going on here. So these pages have been created by ASP.NET Core on the outset. So this is basically what you get, and actually this is a complete website. You can run this and it's going to appear on your web browser, and then you can modify this the way you want until to have a proper and well designed website. But here all we are going to do is to actually show you how to implement caching. Caching can actually significantly improve the performance of your application. You know, the sole purpose of writing applications is to work with data, is to process data, to get the data wherever it is, because data can be stored in different formats. For example, your application might be working with data that is stored on XML files. Your application might be working on with data that is stored on the database, and the database is stored on an external server from where your actual application would be executing. So it will take, or it would be a bit expensive to actually get the data from an external server. So every time a user makes a request of that data, you have to make an external request for the data into your application, do all the processing before you can serve the user. With caching, you are able actually to do what? To only connect once to the data source, and once you connect to the data source, and then you keep that data in the memory of your web server. But you also need to be very careful when you implement caching, because as much as it can significantly improve the performance of application, if you don't do things right, it could actually significantly reduce the performance of your application. So you will have to, or you need to understand actually what you would be doing. And the guidelines, one of the guidelines of implementing caching is that you have to make sure the data that you want to cache is the data that does not change frequently. You can't catch a data that changes frequently, because you are going to actually serve people with an outdated data. So the data to catch, the advice, one of the major guidelines of caching is that you only catch the data that, okay, this data does not change change that much. It doesn't change frequently, so you catch that data. What you don't want is to always connect to the data source every time you want that data, and every time you connect to the external data source, you actually get the same data that has not changed since the last time you have you have accessed that data. So if the data does not change frequently, you have to consider catching that data. But it is also important to note that when you have the data that does not change frequently, it has to be the data that is frequently accessed by the user, that users have to be frequently accessing that data. It doesn't frequently changes, and it is frequently requested by the user. So it is then those are the two things that you have to look. Your data have to be only cached if it doesn't change frequently, and it is frequently requested by the user. So there are other caching guidelines, things like you should not rely on the cache data, because you might not get it, because cache application can only keep the cached data for a certain amount of time, and they should keep the cached data for a certain amount of time to avoid cluttering the memory of the application, and that would also impact the performance of the application. So I don't want to delve into more details with all these guidelines. What I want to do here is to show you how to implement this caching. So now we have created this application. So the next thing to do here is to create the types that we are going to use to actually do this caching. But the first thing that we need to do is to create a folder that is going to hold our model. Does that make sense? And we're also going to create another folder, which is data, which is where our data is. So here, to avoid the process of having to configure databases, we are going to use a physical file. We're going to download a JSON file with a few list of employees. Does that make sense? So now we're creating that employee type. We're going to have this let's say employee root. The reason I'm doing this is because the way that JSON data is structured. So we're gonna have this type. Let's define the namespace first. The namespace, it resides in caching dot model. So this is where it resides, and the type that we want, the first type, okay, we've been waiting for this one. The type that we're going to, it's a class type that we are going to call employee root, and this type is only going to contain one property, which will return as a list of employees. We'll create the employee type just now. Employees, this is an autoprop, an automatic property. This is an autoprop. So we are going to create this employee in a new file. Let's create it in a new. This is the employee type. So this employee type will contain a few properties. Just to save some time, I'm just going to get that from my hard drive, because I've already downloaded that file, so I don't need to go through the whole process again of downloading the file, just to save my data and time. I'll copy this into my, so basically this is the JSON file that we are going to work with. So we're going to define these properties for our employee type. Does that make sense? So the first one is public string user ID. The second one would be public string job title. Okay, cool. The third one, I think I have employee code. Public string. I'm not good in typing. You'll bear with me. Region, phone number, and email address. We going to have region is one of our props. String, email address. Set. Cool. So now we need phone numbers. So just to keep our application simple, all our properties are actually strings. So cool. Now we've defined all these properties. I hope I've defined all of them. Last name, first name. Did we define those ones? Yeah, those ones should be there at the top. Actually, they should have been at the beginning. First name, get, all set. Public string, last name, cool. So now we need to add on these properties to actually try to map, because the way C# or C# properties are named, the way properties of a type in C# are named is totally different to the way properties of a type are named in JSON. Does that make sense? For example, in JSON we use the small letters, while in C# we use the capital letters. Does that make sense? So now this can result into an issue, because C# and JavaScript are, when JavaScript processes a JSON string, it is what do you call it? It is case sensitive. That means this job title is totally different to this job title. So to make sure that the two file, these properties of the JSON properties map very well with the employee properties of in C#, we need to add on these properties specifying the name in JSON. Does that make sense? How do we do that? We do that, we'll use the JSON property. Going to need, okay, we will need to actually download the package where this property is defined, and this property is defined in Neutronsoft. By Neutronsoft, let me see, I think it should be here, Neutronsoft. Yeah, it's defined on this Neutronsoft JSON. So we're going to get that into our application. Cool. Not okay, we need to go to the directory where the project is. The project is at Catching. Cool. So let's add this package. Quickly add that package. So now we do have that package, we just need to use it. So this one defines one of its property. You need to specify the name. So here we will say this property actually maps to user ID. Look at the look at the letters. Look at the letter cases of these two. So now this user ID, this property, this C# property maps to user ID of the JSON. Does that make sense? Cool. So we're going to do that with all the other properties. Here it's gonna be first name and then last name and then fuck you, sorry, job title, employee code. We're trying to map the properties of the two types of languages, the JSON and the C# properties, because the way the properties are named is different. We use different letter cases, so to avoid any confusions when we start to serialize and deserialize, we need this JSON property to do what? To map, to do a necessary mapping. So that is it now. This last name will, with that last name, as you can see, now the letter cases matches. Fine. So now the next thing to do, we do have an employee. Cool. So now what we need to do is to create the page model where we're going to actually make the request of this file. So here is what we want to happen. We're going to create an empty page, and we're going to create a custom pages under pages folder, custom pages with the page that we want. We're going to call that page caching. Does that make sense? So to create a razor page, we use this. Gotta remove create, yeah, it's based on the empty page. Cool. It might give us errors here. We might have an error here because we need to go and add this package to our application, which is the package that does the creation. Cool. We'll go to NuGet to get that. But we should have this. I've been downloading this. I've noticed that. Yeah, we'll just add this one. Cool. This is the package that contains the code to auto-generate the pages. To auto-generate the pages. Come on. Cool. Yeah, it has successfully downloaded that file. So now let's create this page caching. Yeah, should successfully create the page now. That will be called caching. Wait a minute. Okay, there we go. So now we do have this page. Basically there's nothing much here, and all we're going to do is to request this page. This is where we're going to show you how to do the caching. Does that make sense? So the other thing that we are going to do now, we have the model of the data that we want to catch. We also have the source where we're going to get that data. What we need the types that are going to be involved in doing all the process of catching. So now what we need to do, we need to come to model again and create the type that is going to focus on doing the actual catching, and we are going to focus on that type as, we'll say, catch provider. We'll call it catch provider. This is where, and then we'll say it does live inside this namespace, catching dot model. Cool. Now the first thing that we need to do is to define the interface that is going to actually have or write a contract for every service that would want to perform catching in our application to implement. Does that make sense? We have an interface here. Let's do it. Interface iCatch provider. Cool. So this interface only defines one method, and that method returns a list of employee. Then we call that method get employees. Does that make sense? So any type that implements this interface will have to do what? Will have to provide an implementation of get employees, and that is exactly where it's going to perform catching, and then it's also going to do what? To be able to access the data from the main source, which is the file. If it's not available from the catch, then this type should provide, the type that is going to implement this interface should provide what? Should provide a way of getting the data from the main source. Let's do this. Okay, now we're gonna have a type which is going to be involved in doing the catching process, and we're going to call this type catch provider, and we say it's gonna implement this interface, and we say it implements this. When it implements this interface, it should provide the implementation of get employees. So what do we want to happen when this method is called? Cool. The first thing that is going to happen here, we need this is where we're also going to perform our catching. So we use the iMemory. There are different ways to implement catching in ASP.NET, and one of those ways is making use of the iMemory catch, and iMemory catch actually makes use of the memory where your application will be executing to actually perform the catching. But when but sometimes your application may be running on a server that is on the web, that is on the web farm, where you have a lot of servers that have been connected together to actually respond to the same request. Do I make sense? Okay, so let's use this memory catch. So here we are implementing catching using the memory catch. So we keep data on the memory of the computer or server where our application would be executing, and we're going to get this memory catch through dependency injection, the built-in dependency injection of ASP.NET Core. Cool. So we have memory catch. Does that make sense? Should. Okay. Memory catch. Memory catch. Fine. So what this says is that when an object of this type is created, an object of iMemory catch should be injected. If you understand how dependency injection works in ASP.NET, you will understand that actually here you're not gonna receive an object of iMemory catch. You are going to receive an object of the type that implements iMemory cache. Does that make sense? You're not going to receive an object of iMemory. You're going to receive an object that implements an object of the type that implements iMemory cache. I'm going to show you when we do register this service to our dependency injection pipeline. Cool. So let's come here. Let's come back here. So now we do have the cache instance. We do have a reference to where we can perform caching. You know, I love using the try block so that if anything goes wrong here, we are able to catch the errors. Does that make sense? So the first thing that we do is to check if in the memory cache we try to get a value with employees from the collection of values in the memory cache dictionary. We need one with employees keys. Does that make sense? So we have list of employees. Oh shit. List of employees. So what we are doing here, we are actually declaring and passing here what we are doing. You see, if you look at try get value, you'll find that it takes two parameters. The first one is an object, which is basically the key that you are looking for on the cache there. The second one, it's actually the value that is contained by the key, and it is passed as an output parameter. What that means is that the value is going to be assigned by the method that you are calling. In this case, it's try get. So by specifying the type of this parameter, what we are doing, we are also declaring it. So this basically is not different from the doing things like this. Okay, so that you see, if you probably have not been working, you don't know how the output parameters work. Okay, I'll just create a new one. Okay, so we say out. So this is the same as doing that. So to save space, what I've done was to just take this and put it there. We actually have declared, by doing this, we actually have declared a local variable called employees, which is basically takes the list of employees. So I can be able to access that employee on any part here within the if statement, and outside the if statement I'm able to get that parameter, because I've locally declared it by actually and passing it at the same time. So what we are doing here is, if what do we call this? If this does not exist, if there is nothing with employees key in our cache, what do we need to do? We need to go to the source, which is JSON. We need to go to the source and do what? And get then get the data out of the source, and then catch that data, put it inside the memory cache, and then do all what we need to do, which is related to caching. We'll see just now. Cool. So how do we do that? So the first thing that we're going to do is to get, and we'll say employees string. We'll call this employees string. So now we are getting the data from the source. Employee string, again we make use of the JSON convert. Okay, we'll use the system IO. Let's use the system I.io file read all text, and then we're gonna have to go to where this file is, we're going to copy the relative path, not the the relative path is fine. We're going to copy the relative path, but now the problem, we're not going to get what we are looking for from the relative path. We want the full path. Let's make things simple and get the full path. Let's make things simple, get the full path to this thing, so that we don't have to write any extra code to actually get. So now this is where our source is. We are reading this whole file into employees string. Does that make sense? So now we do have employee string as a string. We need to serialize it to be employee root and eventually serialize it to employee. Does that make sense? Deserialize. We're deserializing because we are actually converting a string from a file to a type in C#. So now we are deserializing. So how do we do that? We say, okay, we need an object. It is the way this, the reason we have this employee root, it's just the way this, if you look at it here, you only have employees tab, and then the employees type, it's actually an array of these employees. So the employee root, it's actually a type with a collection or list of employees. I hope this makes sense. Let's see. Employee root, and then we say emp root, and then we say JSON convert dot use JSON convert dot deserialize object. So here we are deserializing into employee root. Then we need to pass the string, which is employee string in this case. So the defaults will do. Cool. Prayer is powerful. Whatever you are, prayer is very powerful. Okay. But I'll tell you why one day I'm saying that. There's something that is happening here outside, but that's fine. So now we have deserialized to this employee root. Cool. Fine. So the other thing that we're gonna need here, we are going to declare a public property which will actually get the list of employees, and we're going to call this employees, and then set. Okay, excuse me. Now, cool. So we have the employee root. So now we are assigning the employees property, not the employees property. Okay, here we are assigning these employees to emp root dot employees. Does that make sense? Just to avoid, I know that this won't be null. So now we have assigned this employee, but this part of the code, you must remember that it's going to execute only if employees does not already exist in the cache. Does that make sense? But if employees does exist, so this part of the code is not going to work. What is going to happen is that the framework or the try get value of this memory cache is going to assign whatever value it gets from the cache to this employee's parameter, and then you can use that. You can actually pass that to other parts of your application. Does that make sense? So here now we have this employee. We need to set the memory cache. The memory cache, employees, need to set this employees, and then we give the value. Here it would be memory cache entry options. Let's start by creating these entry options. We're going to create the entry option. This is where we actually specify how long do we want the system to keep this on the cache, or setting the absolute expiration, sliding expiration, and things like that. So we make use of memory cache entry options, type city cache entry options, and we create this application, this object, and then from that object we are able to call set absolute expiration, which basically gives us how long do you want this to remain on the cache. We don't want this to remain for a very long time. Let's say 360 second, and then we set sliding expiration to time span dot from sliding expiration. It basically means if this does not get accessed within a minute, if this does not if no one accesses, if this employee entry that we are making does not get accessed within a minute, then evict it, take it out of the cache. Does that make sense? But then this is a sliding expiration. Absolute expiration says after, let's say 360 second, I believe it's an hour. After 360 second, you have to remove or evict this employee key from the cache. It doesn't matter whether it was accessed within 1 minute, it has been accessed, it doesn't, but after an hour, remove it. So it's important that when you set these expiration, the absolute expiration and sliding expiration, you will actually want to normally use them together. Because if you only set the expiration, for example, in this case we say set the expiration into an hour, and then if this does not get accessed, it's gonna remain in the cache for an hour without being accessed. Does that make sense? So absolute expiration is going to wait for the time that you set to elapse before it removes this, while sliding expiration does remove it if it's not accessed within this time. So this is important to do, because if you don't do this, then this might result into a lot of problems. For example, you're gonna have a lot of stuff in your memory that are not being accessed as frequently as they are supposed, and therefore using our expensive memory. Memory is very expensive, so it's very important that everything that you keep in your memory, it's something that needs to be in memory. You don't just keep things in memory when there's no need to keep them, because memory is very expensive. So that is why you need to set these expiration. So if something is not accessed within this specified time, then remove it. So it means that it does not need to be there. But if it does, even if it does get accessed within this time, when it has remained this long in memory, you have to remove it to open way for other stuff to be kept in memory. Does that make sense? So now we will pass these cache entry options here. So now we have inserted this list of employees into the cache. Does that make sense? The first time we make access to this memory cache, it's gonna come here, get that from the file, and do all these JSON deserializing, and then keep it on the cache. Then the subsequent requests are going to come from the cache. We won't have to open files and all of that. So we're gonna have an else statement here, which is basically a code that is going to execute if this employee is already in memory. And what do we want to happen when this employee is already in memory? All we want here, we should return employees, guys. Let's return these employees. So here we're also going to return employees. Reference, possible null reference. Okay, let's do this. Hey, this OmniSharp. Cool. So now if this code, okay, let's say if employees is in memory, okay, if employees is not in memory, this is what is going to happen. Eh? If employees is in memory, we're going to return employees. Remember, we said if it's in memory, what try get value is going to do is going to take the value of whatever value is stored in the employees key and put it inside employee. So we'll return whatever is on the cache. Does that make sense? Hopefully it does. So now we have done all the settings. All we need to do is to register this type with our dependency injection. So we're going to program, and then we're going to add our service into the program services. Cool. We're going to use transient iCatch provider iCatch provider provide. Cool. If you have been following some of my videos, you will actually understand what is going on here, because there's a video where I explain what this means. Does that make sense? And I did try, even on this video, to try to explain a bit on this matter. So now we do have this application. Cool. So now what we are going to do, we are going to try to access, wait a minute, yeah, not here. Cache provider will come here. Okay, this is where we want to come. Wait a minute. Yeah, so this is where we want to come. So here's what we're going to do, is to declare a caching model that is going to take the iCatch provider. So we are asking the dependency injection to actually provide us with a type that implements iCatch provider, which is exactly what we were doing here. What we are doing here is that we say, okay, whenever a type of iCatch provider is requested through the constructor, please create an object of cache provider and give us that cache provider. Don't give us iCatch provider, a type of an object of iCatch provider. Give us an object of cache provider. Create an object of cache provider and inject it. That's what we are saying here. We are saying, look, every time we request iCatch provider through our constructor, create an object of cache provider and inject that provider. So here you'll come back and look at cache provider. If you understand object-oriented programming, inheritance in object-oriented programming, you will understand that actually this makes sense, because cache provider is actually iCache provider, as cache provider does implement the interface iCache provider. We say implement here because this is an interface. You can't inherit it, you implement it. But otherwise, this actually means that cache provider is iCache provider. Does that make sense? So it makes sense that when we ask for iCache provider, you give us cache provider, and we are happy to work with that cache provider, because the truth and technically cache provider is iCache provider. I hope I am making sense. If I don't make sense, just comment on the comment section below and let us know what you don't understand. We'll try our best to get you understand these things. So cool. So now here we are requesting iCache provider, and obviously we are going to be provided with cache provider, and cache provider is the one that actually defines the method that we need to call to get the data to do what, to cache, and knows how to perform all the caching. And here also we say whenever an object of cache provider is created, inject the iMemory cache, and it's the same as in here. So basically here we are not going to receive an object of iMemory cache. We are going to receive an object of the type that implements iMemory. Does that make sense? Which that type is the one that defines all these methods that allows us to be able to do all the to implement caching. Does that make sense? So now we're coming here. So we're gonna have a property that is going to store this cache provider that we receive from our dependency injection. Now we're going to have a private property which is going to be of read only, and we're going to have iCache provider and cache provider. Cool. Then say cache provider. Cool. So now everything is sorted. What we need to do, what we can do now, look at what we are doing. Say cache provider dot get employees. We're not going to display these employees anywhere. We're just going to use the debugging tools to actually show you that we have cached the data. So I've set these values, these expiration properties to belong on purpose, because I want you to see that we're going to access this for the first time and access it subsequently as quick as possible within a second, and then we're gonna wait for a minute to see what is happening. Does that make sense? Because we can't actually be able to screenshot our web browsers where you will see these type of things. I'm going to try to get the right tools so that we are able to also screenshot the web browser where all of this is going to take place. But for now, we're going to use the debugging tools. So I'm going to run this application, start debugging. Yes. was tasty. Cool. Application is working. Now we're going to request this page caching. Does that make sense? Cool. Let's go to our browser. You are not able to see it. That's okay. You'll just see the request custom pages. Excuse me. Caching. Let's wait and see, hopefully. Cool. So there's the request. So we call caching. Cool. So now it does not exist. This is for the first time. We open the file, the JSON file, and then we deserialize it. We have these properties, and then we create a cache, we set it, and then we return it to the caller. Did you see? We got the file through from the source, but now we're gonna do another request. Look now, we already have it. We're not gonna come inside this time around. We jump because it's already there, so we're going to get whatever is on the cache. Does that make sense? You can run this, it's going to work. Hope you've understood what is caching. Thank you.